Welcome to Laboratory 7, Simple Machines. Here we're going to set up for the first exercise, inclined planes. So you see before you an inclined plane. And we've got a block of wood on a wooden inclined plane. So for several different angles, I'm going to see how much force is required to pull this block up a ramp. Now we all know when we're moving somebody that it's easier to push something up a ramp rather than just to lift the box straight up. And again, that's because if you sacrifice the distance, you get to push with less force. So what we're going to do for several different angles is measure the force necessary to push this block up a ramp. And then we're going to compare that with the force required to move it directly up, or its own weight. So the first thing we want to do is find the weight of this block. To find the weight, we must first find its mass. Remember, once we find the mass in grams, then we're going to convert it to kilograms. So I'm going to walk over to my scale and let it do its thing. It times out so quickly, I have to keep turning it back on again. 209.8 grams, 209.8 grams. Okay, that's the mass of the block. And I'm going to put a 5-gram mass hanger at the end of the ramp, over the pulley at the end. Then we're going to load it with some mass until the block moves at a constant speed. So it's similar to what we did in the friction lab. There is a little bit of difference. Instead of looking at the forces, we're looking at the energies. The work equals force times distance. So moving the block straight up a certain height will require moving the mass or the weight of the block itself. However, if you move a larger distance, you sacrifice the distance, but you gain a force advantage. So let me just set this up right here. And then I'm going to start putting mass on the end, and we're going to see if at what mass it moves up with a constant speed once I push it. So I put 20 grams on the end. Let's see if that works. Oh, it doesn't even move. Okay, let's put 20 more on. Still doesn't move. So this is a pretty steep angle right now. What I'm going to do is try 3 different angles that are a little bit lower than this as well. Not yet. Let's see, 50 others. Put this on. All right. Let's try again. Not even close. I'm going to increase the amount I put on there. There we go. All right, so let's try this. It's still stopping, but it's getting closer. At least it's moving now. Another couple of 20 grams or so. And I think I ran out of 20 grams. Oh, no, I have one more there. I have one more 20-gram one. Oh, okay, 20 grams is a little bit too much because it started on its own. Let's see, I put a 10 on there. Okay, so let's see. Looks pretty good. So you can see what's hanging on the end. I'm going to go over here and mass it, and I had to turn on my scale again. It keeps turning off on me. I don't know how I can turn off the auto off feature because it turns off every minute. So I've got all my mass on here. It's 125.3 grams. 125. Okay, wait a minute. 125.2 grams. 125.2 grams. Okay. So 125.2 grams. So what does that mean in terms of figuring out the TMA and the AMA? Well, first, before, I'm going to do all the calculations in a separate video. Before we do that calculations, I'm just going to take the height and the length of the ramp. So what I'm going to do now is put a meter stick on here. We're going to measure the length of the ramp. Oh, I've got it flipped backwards, sorry. It's 81.0. Now, technically the meter stick doesn't start exactly at 0. It's a millimeter off. Do you see that? So you gotta subtract off a millimeter off 81. So it's 80.9. 80.9 is the length of the track. And what is its height at this certain point? Okay, measure to the bottom. You've got 20, it looks like, it's coming off. 23.4. So it's 23.3. Got that? Height is 23.3.